Welcome to homework.
This would be our choosing our coordinates. We can essentially just draw the free body diagram, and we're going to choose upwards to be positive y, to the right to be positive x. And then for part B, they want us to find the horizontal and vertical component of the hinge force. So we can apply the sum of forces in the x direction. We know this to be equaling 0, and this is going to be equal to the force of the rope multiplied by sine of phi minus the force of the, we can say, the hinge horizontal. And so the force of the hinge horizontal is going to be equaling the force of the rope times sine of phi, and we can then solve. The force of the hinge horizontal will be equaling 85 newtons multiplied by sine of 37 degrees. This is equaling approximately 51 newtons. This would be our answer, our first answer for part B, the horizontal component of the hinge force. And then applying sum of force in the y direction, this is also equaling 0. This system has static equilibrium as well as translational equilibrium in both the x and y directions. And so the sum of forces in the y direction is going to equal force of the rope times cosine of phi plus the vertical force of the hinge, so hinge comma vert, minus mg minus the weight w. This is again equaling 0. And so we can then say that the vertical component of the hinge force is equaling mg plus the weight minus force of the rope cosine of phi. And so we can solve and say that the vertical component of the hinge force is equaling 3.8 kilograms multiplied by 9.8 meters per second squared plus 22 newtons minus 85 newtons times cosine of 37 degrees. And our magnitude of the vertical component of the hinge force is going to be negative 8.6 newtons. This would be our answer. So that'd be your answer, or two answers for part B. And then for part C, they're simply asking us to find x. So here we're going to take the sum of the torques. This would equal, again, 0. And this is equaling wx sine theta plus mg L over 2 sine of theta minus the force of the rope times L sine of theta minus phi. And so we find that x is equaling the force of the rope times L sine of theta minus phi, and then minus mg multiplied by L over 2 times sine of theta, and then this would be divided by W sine of theta, and we can solve. So x is equaling 85 newtons times 5.0 meters times sine of 16 degrees. And then this would be minus 3.8 kilograms multiplied by 9.8 meters per second squared multiplied by 5.0 meters divided by 2, 2.5 meters times sine of 53 degrees. This would be divided by 22 newtons sine of 53 degrees. And we find that x is equaling 2.44 meters. This would be our final answer for part C. That is the end of the solution. Thank you for watching.